All right, notes on inverse functions. Sometimes we have to restrict the domain in order for our inverse function to be a function. So in order for our inverse relation, I guess we could say, to be a function. So we're going to restrict the domain on original function in order for our inverse to be a function. So we're going to restrict the domain on this function. So this is a function when x is -2, y is 4, x is -1, y is 1, 0, 0, 1, 1, and 2, 4. Each x has a y. So we're going to restrict the domain, and let's just look at maybe 0, 0, 1, 1, and 2, 4. So we're going to get rid of these two because now when I find the inverse, it's 0, 0, 1, 1 now, and 4, 2. We are only looking at the positive greater than or equal to, basically, on the x's. Because when the x's were -2 and +2, my y values had the same, which is this is a function, but the inverse would not be a function. So we restrict the domain to only x is greater than or equal to 0. And now our function has an inverse that's also a function. The next one, restrict the domain to make this function 1-to-1. So we could get rid of this side of it and look at only the x's less than or equal to 0. So we're going to restrict this domain. We're going to change it to x less than or equal to 0. So let's get some points on this graph. So we could say these are 0, 4, and -5, 0. The domain now of this function is -infinity and stops at 0. And my range is -infinity until 4. So on the inverse, then, my domain now will be -infinity to 4. And my range will be -infinity to 0. So what does that look like? I flip those points around, so my inverse points will be 4, 0. So this is now my inverse, 4, 0, and 0, -5. Now how to draw this thing? Well, my domain goes from -infinity to 4, and my range goes -infinity to 0, so it's everything this way. And that is a function. All right, find the inverse of f. Find f raised to the -1, or f inverse. So find the domain and range of this function. Well, if I were to graph this thing, it would graph at over 5, up 3. But it says all my x's are less than 5, so I'm going to get rid of these here, so that's not going to exist. So my graph only looks this side of it. Get rid of that again. I didn't like that. So now my graph is only all my x's are less than or equal to 5. So my domain of this function is -infinity to 5. And you can see your range is 3. Make that a bracket on 3 to infinity. So then if I'm looking at the domain and range of my inverse, so the inverse function, my domain will be 3 to infinity, and my range will be -infinity to 5. So let's get the beginning of my graph here. So over 3 down, or over 3 up 5 now. And which way? So my domain is 3 to infinity, so it's going to go to the right, but my range goes -infinity to 5, so I know this then is my new graph. Let's write the equation. So my inverse, I switch the x and y, so it becomes x equals 2 parentheses y minus 5 quantity squared plus 3. Move over your 3, so x minus 3 equals 2, parentheses, y minus 5 squared. Divide by 2. So x minus 3 over 2 equals y minus 5 quantity squared. So we're going to take the square root, and normally when we take the square root, we write plus or minus. But since we're interested in the negative, where this graph is opening down, we're going to have negative of x minus 3 over 2 equals y minus 5. So negative square root of x minus 3 over 2 plus a 5 equals y, and that's going to be f inverse because we restricted the domain on the original function. All right, next one. Let's change colors. So this would be, let's see, f of, so my domain of this function, well, my beginning of this graph is I go left 2, down 3. And it has a negative in front, so this thing opens down. Let's go right 1, down 1. That gives me my graph. So my domain here is bracket negative 2 to infinity. And my range is negative infinity and stops at negative 3. So in the inverse, my domain now is negative infinity to negative 3. My range will be negative 2 to infinity. Let's get a sketch of that. So negative 3, negative 2. So my domain is everything to the left. And my range goes up. So this thing is going to do something like this. Let's find the inverse. So you'd have x equals negative square root of x plus, or x, how about y plus 2 minus 3. So add 3. So x plus 3 equals negative square root of y plus 2. Going to square both sides. So x plus 3 quantity squared equals square a negative, you get a positive, and square the square root, we just get y plus 2. Finish this out, we get y equals negative 2 plus x plus 3 quantity squared. So f inverse is x plus 3 quantity squared minus 2, but make sure we stipulate the domain. My domain is x has to be greater than or equal to negative 3. No, x is less than or equal to negative 3. Because how the domain, how the range originally happened, now all my x's have to be less than or equal to negative 3. My middle looks like over 4, down 3. Oh, let's graph. Let's worry about the inverse. So this is the original graph. So my inverse, let's go with the new color here. So inverse would be, domain will be negative 3 to infinity. And range will be negative infinity to 4. So that looks like it will be at, so back 3, up 4. Now how does this thing, so on this, we're going to my XY chart on the inverse, we just flip those. So negative 3 is 4, negative 2 is 3, negative 1 is 0, and 0 goes to 5. So back 3, up 4, we have that point. Back 2, up 3, negative 1, 0, and then we have 0, negative 5 should be negative 5. So I can see this graph does this forever. Nope, not up here. Then if we want to find the equation, so we would say x equals, so the inverse equation would be x equals square root of 4 minus y, then minus 3. So add 3, we get x plus 3 equals square root of 4 minus y. Square both sides. So x plus 3 quantity squared equals 4 minus y. Subtract 4. So x plus 3 quantity squared minus 4 equals negative y. Divide everything by negative 1. So we have negative of x plus 3 quantity squared plus 4 would be my f inverse, with the domain x greater than or equal to negative 3. All right, find f inverse by restricting the domain of f. So if I have 3 minus x squared, so that is a parabola opening down. So I could restrict this domain by saying x could be greater than or equal to 0, all that I would need on that function. Then I could find the inverse. Or you could say, let's say, x less than or equal to 0. So that would be 2 possible choices for how we could restrict the domain. State the transformations and graph f of x, then graph the inverse. So this graph would be the vertex at 1, 2. But all my x's are less than or equal to 1, so I'm only interested in this side of that. So my domain is negative infinity to 1. And my range would be bracket 2 to infinity. So if I were to graph the inverse, my domain now is 2 to infinity. And my range is negative infinity to 1. So now it's at 2, 1. And my domain goes to the right from 2. My range is negative infinity stops at 1, so I can see this graph is going to do something like this. All right, so this is the inverse this side. Let's do the next one here. So if I were to find the vertex of this parabola, it'd be back 3, down 1. And then all my x's are greater than or equal to negative 3, so it's only this side of it. So my domain is negative 3 to infinity. And my range is negative 1 to infinity. So then if I'm looking at the inverse, my domain now is negative 1 to infinity. And my range is negative 3 to infinity. Back 1, down 3. So domain going to the right from negative 1. My range is negative 3 to infinity. So my graph will be something like this. All right, last one. Decide whether the functions are inverses of each other. So what I'm looking for is that f of g of x, we want to prove it equals x. And we want to prove g of f of x equals x, always. All right, so domain of f, if I have negative square root of x, my domain would be bracket 0 to infinity. And my range are the outcomes, and so that's always a negative number, so negative infinity to 0 with the bracket. On g of x, that's just an x squared function, so a parabola, so my domain is everything. And my range will be 0 to infinity. So f of g of x would be f of x squared. So f of x squared would be this negative square root of x squared, which if x is a positive number, so if I have 3, if I square 3, I get 9. Square root of 9 is 3, so it's negative 3. But what if I have negative 3 quantity squared, I get 9. Now, so you get negative 3. So my solution is plus or minus x, depending upon if x is positive or if f is negative, or if x is positive or if x is negative. So then we need g of f of x will be g of negative square root of x. So I'm taking negative square root of x and squaring it. So no matter what, I'm just going to get x. Because that x, what that stipulation here is, this x has to be greater than or equal to 0 for that to hold true because of that domain. But up here, my x in this problem of x squared, so my domain was negative infinity to infinity. That's why I can get plus or minus x. So are these inverses of each other? The answer is no. But what if g of x equals x squared and all my x's are less than 0? So if all my x's are less than 0, if I take the square root of negative 3, let's say squared, negative on the outside, so this is negative of square root of 9, which is negative 3, which is negative of negative 3. Nope. I think we just want to say negative 3, which is my x that I started with. So if g of x is x squared, x less than or equal to 0, it's always and forever x, then that it would be an okay. They would be inverses.